In order to solve these two problems, we're going to write a system of equations to solve. So let's take a look at the first one here. Sam spent $24.75 to buy 12 flowers. And roses cost $2.50 each, daisies $1.75. It asks us to find out how many daisies were there and how many roses were there. We know there's 12 altogether, but we don't know how many daisies and how many roses add up to make that 12. So what we're going to do is we're going to write two different equations. Let's take a look at our two different equations we're going to use. We're going to use what I call a quantity equation, and then I'm also going to have a value equation. And a lot of these problems that we deal with can be set up using a quantity equation and a value equation. Quantity is the number. So 12 flowers. We just don't know how many roses and how many daisies. And really, that's the question. So let's do this. Let's call roses, those are going to be R for roses, and D for the number of daisies we buy. So we don't know how many roses, but there's R number of them, plus the number of daisies, but we do know those numbers add up to equal 12, because that's what it says. There's 12 flowers altogether. Well, their value, $2.50 is the cost of a rose. So 2.5 times the number of roses. And we have $1.75 is the cost of a daisy. So we'll write 1.75 times the cost of a daisy, or how many daisies we buy. And altogether, this will make $24.75. So we've got an equation. R's and D's are all lined up. We could go ahead and use either method, really. I'm going to go ahead and I guess I'll go ahead and use the elimination method this time. So I'm going to multiply to try to cancel out one of these terms. And as I think about it, it might be easier to multiply by 2.5. 1.75 times 12 would be a little bit tougher. So I'm going to multiply this whole equation here by negative 2.5. And that way it can cancel out the 2.5 in this equation. So I've now got negative 2.5r and then minus 2.5d, and this all equals, and then when we double 12 we get 24. Half of 12 is 6, so 24 plus 6 makes 30. So this number is going to be negative 30. So now we need to add these numbers together. And so when we do that, we're going to end up canceling out some terms here. So we just do 2.5 minus 1.75 because they're opposite in sign there. And so that's going to leave us with a 75.75, so 75 cents for the most part. So that negative 0.75d equals, and then we do the 30 minus 24.75. And make sure you're really careful doing this subtraction because you do have to borrow when you do it. And it gives us negative 5.25. Well, all we have to do from that point is a division problem, and we'll have our answer. So basically we're dividing by negative 0.75. Negative 0.75. And it's a good calculator problem here. So we divide by 0.75, and this will equal 7. So there it is. D equals 7. So now we know the number of daisies we bought. It's real easy to substitute that 7 right back in for this D and find the number of roses. So roses equals, or roses plus daisies, I'll go ahead and do, R plus 7 equals 12. So all you have to do is subtract that 7, and you get yourself an answer. R is 5. And so 5 roses, 7 daisies was the answer. Well, this next problem is, well, different in that instead of roses and daisies, we're talking about types of tickets, either student tickets or non-student tickets. But it's set up the same way. It's still a quantity value problem. See, it gives us 358 tickets to the basketball game were sold. The value of those tickets was $752.25. We have two different types of tickets. Student tickets $1.50, non-student tickets are $3.25. Very similar to this problem here. So it's the same type of problem. It's another quantity value problem. And so those are the two different types of equations we're going to set up. Quantity equation. Well, we don't know how many non-students ended up showing up. So why don't we call the non-students N? And the students, well, if we were really careful, I guess we could use S to make sure that doesn't look like a 5 at all. So we'll use S for non-students. So S are for students. S plus N equals 500, or 358. That was the number of people who ended up attending. And then we have the value equation. The value is $1.50 for students. So 1.5 S, and then plus, and we have $3.25 times the number of non-students equals, and then the total taken was $752.25. All right, well, elimination is a good method. We'll try it again. We could multiply that top equation by some number. Now, it would be easier to multiply it by negative 1.5, because 1.5 is easier to multiply than 3.25. So we go ahead and do that work. Negative 1.5 S, and then minus 1.5 N equals, and then 358 times by 1.5. So again, you're just basically taking half of 358 and adding it to 358, and that gives you negative 537. So I go ahead and add these numbers together. When they're opposite signs, you will end up subtracting. And so here we have to subtract 3.25 minus 1.5. That gives me 1.75. N equals, and then careful on this one, you got to add those zeros after that 537. So that's 752.25 minus 537. That gives us $215.25. Well, from that point, all we have to do is one division problem. We've got our answer. So again, this would be a good calculator problem. We go ahead and divide by that 1.75, and we'll have our answer. So when we do that, N equals, and we have 123 is the number. So N is 123. Those are the non-students who ended up showing up. Got that number. And then all we have to do to find out how many students ended up showing up is do that. You put it into that quantity equation. S plus 123 equals 358. And so if we just do that one operation of subtraction from both sides, we'll have our answer. So we're going to minus 123. Minus 123. And we've got our answer. S equals, this makes a 2, 3, and this was a 3 here, so that would subtract to make 5. So 235 was the number of students, 123 was the number of non-students. So quantity value problems, typical type of problem that are used to set up systems and solve.